fellow geocache teams and friends of the Challenger Center, my name is Tess Caswell, and while I'm currently a graduate student at Brown University studying ice and the moons of the outer solar system, I used to be a flight controller for the International Space Station. In mission control, I was responsible for the environmental and thermal operating systems of the space station. That means I was in charge of the air, the water, and the temperature on board the space station. I was also responsible for guiding the crew and the mission control team if an emergency happened on board the space station. Now, if any of you have done a mission here at the Challenger Center, you've probably experienced emergencies as well. For instance, a solar flare has a tendency to happen while you're on your way for a rendezvous with a comet. However, with the real space station, we don't worry about solar flares as much as we worry about a rapid depressurization of the space station. That is, if a meteor strikes the space station, putting a hole in the pressure shell and making the air leak out into space. To give you a taste of what that's like, I'm going to play for you some clips from a simulation, just like the ones done at the Challenger Center, but done with real flight controllers and astronauts with a space station simulator.
Okay, thank you. And there are no issues with the S01 MDM, correct?
No issues.
Okay, good to know. Thank you.
Houston flight SRP.
Houston flight SRP.
Echo, sir.
Go ahead, SRP.
Слушаю вас, SRP.
Ну я
Break,
вот
break, flight ethos.
со своими...
Stand by, SRP. Stand by.
I see a rapid depress. I need the team in 1.3 of the Red Book.
1.3 of the Red Book. Copy that.
And flight SLC control course looks like a real rapid depress.
Copy. Station Houston on Space to Ground 1 for emergency.
Go ahead, Houston.
Yeah, we see a rapid depress in progress. You can probably tell with your ears. We need you in 1.3 in the Red Book.
Right now, I expect both crews to be in their Soyuz performing leak checks.
Okay.
Flight Cronus.
Cronus.
Go to configure for emergency comm.
Affirmative.
And Station Houston on 1.
Ethos here.
Go ahead, Station.
Both Soyuzes look good. Repeat, no leaks in the Soyuz. We're going to leave ours and go proceed with leak isolation.
Copy all.
Not as exciting as Apollo 13, is
Ethos
it?
concur.
But one thing's for sure, if there's a leak in your space station, you want the ground control team to be so good at taking care of those things that they could do it in their sleep. Which was good, because those simulations usually started at about 6:30 in the morning. My path to NASA started when I was 10 years old, and I began volunteering at the Challenger Center. This was probably the first, but definitely not the last time I was seen in public wearing a spacesuit. I graduated from SoHi and then attended the University of Alaska Fairbanks, where I discovered the Alaska Student Rocket Project, which, much to my surprise, had a sounding rocket launch facility and a group of students who were building a sounding rocket payload to launch. As a member of the Student Rocket Project team, I helped build that payload and then helped launch it 100 kilometers into the D region of the ionosphere.
8, 7, 6, 5, 4, 3, 2, 1.
Very cool.
Waiting for the sound.
Also, while working with the Space Grant, I had the opportunity to fly twice aboard NASA's reduced gravity aircraft to experiment with small satellite control systems in zero gravity. That whole sequence of events started with the Challenger Learning Center of Alaska. As you probably know, because you're there supporting the center tonight, CLCA is an integral part of science education on the Kenai Peninsula. Thank you for supporting it. Good luck with your Geocache Rally results, and I hope you have a great rest of the night.